In this chapter, we're going to look at rational expressions. In this lesson, we're going to look at adding and subtracting rational expressions.
Okay, hi everybody. So in this lesson here, like we said before, we're going to be talking about adding and subtracting rational expressions, which is something that you've done before. I mean, you're adding and subtracting fractions, right? And so the same sort of ideas hold here, right? We're going to find a common denominator and then we're going to add or subtract the numerators. But it is a little bit different when you're dealing with rational expressions because we're going to be dealing with polynomials mixed in there. And so that adds just another layer to the process here. So let's just talk about our steps here. First of all, we're going to factor all denominators. And actually, it's probably not a bad idea to factor all numerators as well so we can do some simplifying. Okay, so I mean, if you can, it's going to help to simplify right away. Makes things a little bit easier, makes the expressions a little bit smaller, easier to work with. Then we're going to choose the lowest common denominator. I'm just going to have one of each factor, or as many as you need of each factor there. Always check if you can cancel on the top or the bottom, the numerator and denominator, before choosing the lowest common denominator. That little bit here is kind of referring back to that simplifying. You know, make sure that you've factored and you've simplified before you start choosing your common denominator. Then we want to make sure we state those NPVs, those non-permissible values. Okay. In the questions that we're doing right now, that's just going to be something that we do in addition to the work. But later on, when we start to solve equations, we're gonna want to refer back to those NPVs just to see if the solutions that we find are actual solutions or not. We're going to multiply the numerator by the missing common factor, okay, which you've done that before. Anytime you've added or subtracted fractions here, you've done that. You got to multiply the numerator and denominator by the same thing. It's just that now we're going to be dealing with polynomials, okay? Those are the objects that we're going to be working with. So it's just a little bit more complicated. And then we're going to add and subtract the numerators, just like you would before. You know, prior to this, when you're working with fractions, you'd have added and subtracted those numeric values. Well, now we're going to add and subtract the polynomials that we get. In any case, this is one of those things where it's kind of hard to explain. What we want to do is we want to go through a whole bunch of examples and make sure that you've seen a bunch of variation with this so that you know how to handle the questions as they come. So let's go take a look at some examples here. Okay, so we're going to add or subtract the following rational expressions. So here we go to start off with here. And for the first one that we're looking at here, we've got 2 over x plus 4 over x. This is wonderful. The denominators are the same. So what I can do here is I can focus my attention just on the operation in the numerator. So that's going to be 2 plus 4 in the numerator over x. And so 6 over x. And then, like we stated here, we want to state or want to include as kind of a recognition of the non-permissible here. We know that x cannot be equal to 0 because that leads to that is a non-permissible value here. That leads to division by 0. For b, okay, it's a little bit more complicated because the denominators are different here. Now, they're both prime numbers, though. So the easiest thing I can do here is multiply each denominator by the other one. Okay, and that's about it. Now I'm going to get a common denominator of 14 when all said and done. In my numerator, I'm going to get 7 times 5d is going to be 35d. And then that's going to be 3c times 2, or 6c. Okay, good. Now, what are my non-permissibles? Well, there aren't any because I've got a 14 in the denominator. So that's not a problem. The non-permissibles pop up only when I've got a variable in the denominator that might cause, depending on its value, it might cause division by 0 to occur. For question C, taking a look at that, I've got 11 over a plus b and then 7 over b plus a. Now, those maybe at first look a little bit different, but remember, order does not matter, okay, for addition. And so I can actually rewrite that as subtract 7 over a plus b. And so the denominators actually are the same. I'll move the numerators together. I'm going to do that operation. So an 11 minus 7 here is going to be, what is it? It's going to be 4 over a plus b. Now, there is a non-permissible here. Now, when we've got a plus b in the denominator, I'm just going to do this off to the side here, okay? My denominator can't go to 0. So it's a plus b that I don't want to equal 0. That's the issue here. Now, I've got two variables here, but only one equation to work with. The best that I can say here really is I don't want a to be equal to the negative of b. Okay, don't want that. So that is my restriction here. Those are my non-permissibles. A cannot be negative b. Okay. Now you might say, well, wait a minute, couldn't I just say a can't be 0, b can't be 0? Well, that's true. But a can't be 2 and b can't be negative 2 as well, because that leads to a 0 in the denominator, and I don't want that. So that's how I want to deal with that in general. For this next one, for D, once again, I'm pretty happy that the denominator is the same for both expressions here. Where I run into difficulty with this one here is with that subtraction. So the numerator becomes 3x minus. Now, if you just write it like this, that's incorrect, okay? Because I am subtracting that second term there. I am subtracting that 2x plus 5 here. This negative that I'm seeing here, the subtraction, distributes to both of those terms. If I just write it as negative 2x plus 5, I haven't distributed that negative. So this should become 3x minus 2x minus 5 all over x plus 4. And then 3x minus 2x is just x. There are no common terms with that negative that I can put together with that negative 5 over x plus 4. And then my non-permissible value here is going to be that x cannot equal negative 4. If x equals negative 4, then x plus 4 goes to 0. And I don't want that. For E, okay, for E, there are a couple of ways that I could do this. And there is one way that's probably a little bit more straightforward. But on the other hand, one of the things that I like to do with students here is I like to point out places where expressions don't quite look pretty, okay? And this little bit here doesn't quite look pretty. I don't really like how that looks. So I like it more when the x is first. So I'm just going to switch the order of those two. Okay, I'm just going to switch the order of those two. Now, the denominators are still not the same because I've got negative x plus 2 in the first term, and I've got positive x minus 2 in the second term. So what I'm going to do here is I'm going to factor out that negative out of the denominator in that first term. That's going to leave me with this expression right here, x over negative x minus 2 minus 2 over x minus 2. And now I have the freedom to be able to move that negative up to the numerator. So that expression is equivalent to this. And now I'm thrilled with that. The denominators are the same, so I'm just going to make that negative x minus 2 over x minus 2. And there we go. Now I can't cancel the 2's. Okay, I cannot cancel the x's there. You would have to do the order of operations here. That division implies a set of parentheses around numerator and denominator, and I would have to do those operations first before I can go across that division symbol there. So that's as good as that's going to get. But I can say that x cannot equal positive 2, because if you plug 2 into the denominator, 2 in for x in the denominator, you get 2 minus 2, and that's a 0, and we don't want that. All right, let's keep going. The next one here. I got a similar sort of thing going on. I want to make this a little bit prettier, and it's this time it's that second term that's causing me the issue. That denominator here, I'm going to move that around, so it's going to become negative x plus 1. And then I'm going to pull that negative out. Oh, and it's looking good here. Now I'm going to move that negative in the denominator up. Now, that's going to give me a subtraction. And I'm going to minus a negative term here. Actually, those are going to cancel each other out here. So I'm going to be left with x over x minus 1 plus 2 times 3x minus 2 over x minus 1. The denominators are the same. So I'm going to put the numerators together, and that'll be x plus, and I'm just going to distribute that 2 through. That'll be 6x minus 4. And so 7x minus 4 over x minus 1 is my final result there. And with the restriction that x cannot equal positive 1. Because if you do, the denominator goes to 0. Okay? Next. Okay, well, this one here, I'm going to have to do just a little bit of work on this one. Prior to this point here, the factoring that I've done thus far has really just been moving negatives out. Well, here I got to do just a little bit more. In that denominator, I've got a common factor of x. So I'm going to pull that out here. Now, this is a great question. This is a really good question here. Because I could do this a couple of different ways here. I could treat this as if the common denominator is x times x minus 1. And then what I could do is I could multiply that second term, numerator denominator, by x. Or I could notice that there's an x here and an x there, and I could cancel that. And then what that leaves me with here is 6 over x minus 1 plus 7 over x minus 1. Now, I got to stop here for just a second and say, well, wait a minute. I canceled out a variable from the denominator. That variable in the denominator was introducing a restriction in this problem here. I can't let x go to 0. At this stage right here and at this stage right here, if you let x go to 0, that thing becomes undefined. Now that I've canceled that out, that 0 is no longer a problem. But it was a problem in the question, so I can't just ignore the fact that was an issue to begin with. Even though right now, at this state that I'm at right now, it's not causing me a problem. If I could plug a 0 into that, it won't be an issue here. But because it was an issue in the original question, I have to acknowledge that here. Now, because the denominators are the same, I can simply put the numerators together, and I get 13 over x minus 1. And I've already established, and actually I'm going to just give myself an eraser here. Clean this up just a little bit. Okay. I'm going to state here that x can't be 0, but it also can't be equal to 1. Right? Because if x is equal to 1, then the denominator that I'm seeing right there, that goes to 0. So there is a non-permissible that kind of disappears, and there's some vocabulary that goes with that, and you'll talk. Whoops! Oh, I forgot to switch that. There is some vocabulary that goes with that kind of a discussion that you will look at in a later course here. Okay, so now let's move this up a little bit. Keep going. So here I've got a plus 5 over 7a plus 4 over 3a squared. Okay, so in this case right here, it's not really about factoring. Okay, because my expressions are both monomials, but notice that I've got a factor of 7 and a factor of a, factor of 3, and then 2 factors of a in the denominator. So I need to introduce another factor of a here and a factor of 3. And then here I have to introduce a factor of 7 in order to get common denominators. So now actually, you know what? I'm even going to do it down here. My overall denominator is going to end up being 21a squared. And then up here, I'm going to distribute. That's going to become 3a squared plus 15a plus 28. And actually, that's okay. I'm okay just leaving it like that. That's good. So now I'm just going to put a comma here, and I'm going to list my non-permissible, which in this case is 0. Okay, notice that 0 isn't always a non-permissible value. Okay, if the variable is by itself as a factor in the denominator, then yes, it is. But if it's in a binomial or something like that, then it's a little bit more complicated. In this next one, I've got a factor of x plus 3 in this denominator and x minus 6 in this denominator. So what I got to do is I got to multiply those together. So my common denominator is going to be x plus 3, x minus 6, which means in that first term, I had to multiply 3x by x minus 6. in that second term, I had to multiply, whoops, sorry, I forgot the x. I had to multiply 4x by x plus 3. So now I'm going to leave the denominator factored. You're going to find that that's probably pretty standard. I think most teachers would approach it that way. And now what I'm going to do is I'm going to distribute to get 3x squared minus 18x. And when I distribute that 4x, I'm going to bear in mind that there's a negative associated with it. So negative 4x squared minus 12x. And when I put the pieces together, I will get negative x squared minus 30x all over x plus 3, x minus 6. Okay. Now that looks pretty good to me. I'm just curious, if I factor the numerator, and the only thing I can really do there is maybe take out a negative x, I will get x plus 30. Okay, nothing cancels. I was kind of hoping that something would cancel in there, right? That I would see a shared factor numerator denominator, but I don't. And so now I'm going to state here that x can't equal, and what are my two numbers? Are going to be negative 3 and positive 6. Whoops. Okay, and those will be my two non-permissibles. Oops. Let's keep going. For this question right here, okay, well, I got to do a little bit of factoring. So I notice that my denominator here is a difference of squares, so it's going to be x minus 2x plus 2. And then here I've got 3x over, okay, I can take out a common x. Okay, and I've got 3x over x plus 2. But as soon as I do that, I notice, look at that, I've got a common x numerator and denominator. Okay, so I can cancel that out. And so this expression is going to become x over x minus 2x plus 2 plus 3 over x plus 2. Okay, well, that makes things a little bit easier. Now, I do need to recognize here that I just canceled an x out of the denominator. And because the x was in the denominator, there is this restriction that x can't be 0. And that's going to stay with me. Even though the x is gone from the denominator, that restriction stays. Now what I'm going to do is I'm going to get that common denominator. I'm going to get that by multiplying that second term by x minus 2, numerator and denominator. And bear in mind that x still can't equal 0. And so this is going to get me x plus 3x minus 6 when you distribute that through, x minus 2x plus 2. X can't be equal to 0. And then finally we get, putting that all together, 4x minus 6 over x minus 2, x plus 2. And comma, I don't want to run into the next question here, so I'm just going to write x can't equal 0. That was what I got early on here. And now looking at my denominator, it also can't be equal to either plus or minus 2, because that's what creates zeros in that denominator there. In this next question, okay, well, this one is actually, in a sense, backing off a little bit in terms of difficulty. My denominators here are 5 and x plus 3. So my common denominator is just going to be the product of those two, meaning that that first term I have to multiply numerator and denominator by x plus 3. And in my second term, I'm going to multiply numerator and denominator by 5. Distributing that through, I get x squared plus 3x plus, and then 15 over 5 times x plus 3. And you know what? There's really no reason to go any further. That's good. There's no more like terms to combine. Now, you might think about factoring that, but actually it's not going to factor here. So we're basically done here. All that's left for me to do is to state that non-permissible. X can't equal negative 3. Okay, and again, we're getting that non-permissible because that's where the denominator becomes 0. That's where this term goes to 0. And then 0 times 5 would be 0. This next one here, basically, I'm just going to end up multiplying those two denominators together. So my common denominator is just going to be the product of the two individual denominators. So the first term, I have to multiply numerator and denominator by x plus 4. And that second term, I got to multiply numerator and denominator by x minus 3. So, and like we said before, we're going to leave the denominator factored. It's just easier to work with that way. But up here in the numerator, we're going to get x squared plus 4x when I distribute that x through. And now I'm going to factor out the, I'm going to multiply out or expand out the product of these two binomials. Now, in addition to those two being multiplied together, there is a subtraction there. I'm going to leave that for just a bit. When you multiply x minus 1 times x minus 3, I'm going to get x squared minus 3x minus x plus 3. Okay, when I distribute the different pieces through there. And so now, my denominator is still x minus 3, x plus 4. This is going to become x squared plus 4x. Okay, so here, those two together become negative 4x. So when I move that negative through, I'm going to get negative x squared plus 4x. The sign will change, minus 3. And I think I'm basically done because the rest of it's going to be pretty straightforward. The x squareds are going to cancel each other out. Positive x squared minus x squared. And so I'm left with 4x plus 4x, 8x minus 3. And now I'm going to identify from the denominator that x cannot be equal to positive 3 or negative 4. Right, now this next question, a little bit different, and it's multiple choice here. So the dimensions of a rectangle are represented by the rational expression. Okay, so there we go. And we want to figure out the perimeter. Okay, well, the perimeter is twice the length plus twice the width when it comes to rectangles here. So twice, that'll be 2x minus 1 over 5 plus twice x plus 2 over 3. Remember that multiplying by 2 means I'm going to multiply the numerator by 2. So this becomes 4x minus 2 over 5. Multiplying that rational by 2 means I'm multiplying the numerator by 2. So 2x plus, whoops. Sorry, I was just about to write that wrong, even though I was going to say it right there. 4 over 3. And now to get the same denominator, which in this case is going to be 15, I've got to multiply that first expression through by 3. Oops. Sorry, I said 3 and then I wrote it. Okay, hold on, I'll do that again. So minus 2, and this will be plus 5 multiplied by 2x plus 4. So this is going to become, all over 15, 12x minus 6 plus 10x plus 20. And 12x and 10x is going to be 22x. And actually, that's as much as I need because I can tell right away that that's going to get me the 22x, and then negative 6 plus 20 is going to give me the 14. So there we go. That's what I was looking for. And now for our last question that we're going to work together, it says the perimeter of a triangle is the sum of all its sides here. The perimeter of a triangle is x plus 33 over 5x, where x greater than 0. The sum of two sides is 6 over x. What's the remaining side? Okay, well, so the perimeter is going to be, side 1 plus side 2 plus side 3. Well, we already know that the perimeter is x plus 33 over 5x. I already know that. And it tells us that the sum of two sides is 6 over x. So let's say it's the sum of those first two. So 6 over x. And we just want to figure out what the remaining side is. So to do that, we're going to take x plus 33 over 5x, and we're going to subtract 6 over x. And that should equal the length of the third side. Well, my common denominator here, I'm simply going to multiply over here this denominator by 5. That's the factor that's missing there. So that's going to get me x plus 33 minus 30 over 5x. And if we put together the like terms, we're going to get x plus 3 over, x plus 3 over 5x. The denominator stays the same. And so that is going to be D. Okay. So I know that was a lot of me just kind of going over it, blah, 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 blah. But yeah, I hope that kind of repetition and seeing it happen kind of again and again here starts to to make sense and you start to see the pattern and the flow of these sorts of questions.